Okay, we're looking more transport across membranes. We're going to group two things together here, active transport and co-transport. They're very similar, that's why I put them together, but they do have one significant difference. Okay, so active transport, let's start against that. You're going to use these 3 bullet points whenever you're talking about active transport. It goes, most importantly, against the concentration gradient. Okay, how does it do that? Well, it's fighting the laws of physics, so you need some energy to do that. So using energy from ATP. Very important, you use the words ATP there. And how does it go there? It goes via a carrier protein that we looked at with facilitated diffusion. Well, whilst we're on the subject, let's just move across and see how co-transport's different, then we'll do the diagram. It also uses a carrier protein, so via, it moves 2 molecules at once. One of them goes down the concentration. So one goes down its concentration gradient. Remember this for concentration. I often write conc grad for concentration gradient if you're writing a lot in your own notes, but remember to be consistent. If you use it once, use it a lot, and then it saves you time. If you use it once and then never use it again, you'll look at your notes in May and you'll think, what the hell does that mean? The other molecule piggybacks kind of on the ride, goes against its concentration gradient. So we're going to draw these diagrammatically. First of all, I'm going to draw a little bit of the outline and we'll speed the video up so you're not left there waiting. Okay, so with active transport, we've got this molecule of glucose. In this case, it's just drawn a hexagon. It's going to come from outside the cell to inside the cell. The cell's got lots of glucose in it. Outside the cell doesn't have very much glucose in it. So it uses a molecule of ATP and just pulls it in via a carrier protein. Similar drawing. Again, I'll be quiet and draw the diagram, and then we'll see how we go, and I'll give you an explanation. Okay, so what's happening here? We've got glucose still. This is it's low concentration outside the cell, high concentration inside the cell, so nothing's changed in terms of the glucose. But the difference is there's no ATP used in this diagram. We're using the concentration gradient of sodium in this case. Let me label what I have here. Equals Na plus, in this case, equals glucose. So the glucose is getting pulled into the cell using the concentration gradient of the sodium. So this is flowing down its energy gradient, and glucose is just piggybacking off that energy basically. And it's as simple as that.